Hello, seventh graders. I'm so happy that you are able to watch this video in case you do not make it to your classroom's Google Meet. All right, so today we are moving on to solving proportional relationships. All right, so this ties in with so many different type of architecture and measurement. Cooking is a real life skill that you will need to use in your life at some point. Okay, so we have solved whether a table or a graph is considered proportional. So now we are going to take some other situations and find out if they are considered proportional or find our missing value that should fit for two fractions that are equal to each other. Okay, so we are still in chapter 1 in volume 1. And this is going to go after our insert of graphing proportional relationships. All right, so if you're keeping your notebook nice and organized, that's where it goes. Alrighty, so we have fruit smoothies. Kate and some friends want to buy fruit smoothies. They go to a health food store that advertise a sale of 2 fruit smoothies for $5. Okay, so fill in the boxes to write a ratio that compares the cost to the number of fruit smoothies. So right there tells us how to write our ratio. We are going to put cost on top and then fruit smoothies on the bottom. Well, what does the sale tell us? The sale is telling us that there are $5 for 2 smoothies. That's our ratio. Okay. So suppose Kate and her friends want to buy 6 smoothies altogether. So how much would that be? Well, if we actually had some type of way to figure this out, if we're doing 5 smoothies and we would double it. That's the same as having 4 smoothies, right? Well, 2 times 2 is 4, 5 times 2 is 10. What about then if we had our 6 smoothies? We would then multiply by 3. So 5 times 3 gives us $15 for the 6 smoothies. All right, those are all equivalent ratios. All right, so is the cost proportional to the number of fruit smoothies and 2 and 6 smoothies? We would say, let me tap it. Where'd my typing go? All right, well, I had it typed there. There we go. Yes, all ratios then reduce to 2.5. All right, so if I took my 15 divided by 6, I would get $2.50 per smoothie. The same thing if I took $5 and divided by 2. So, and remember, being proportional means all of the ratios are equal. So remember, a portion is an equation stating that 2 ratios or rates are equivalent, equal, the same. All 3 words go together. Equivalent being your more mathematical 7th grade level term. Okay, so we're going to actually work with doing this. Okay, so to find cross products, we are multiplying diagonally. Okay, so we want to actually take the numerator from one fraction and the denominator from the other and multiply them. And whatever their product is should equal the same as the other product that we go across. So if you look at example 2 here, we know we need to take 8 times 3. Okay, my numerator, my denominator. Not from the same fraction, from different diagonal forms. Then we have 6 and 4 that we are multiplying. These are all different numbers, but their products get the same. So these are equivalent. So 6/8 is equal, the same, equivalent to 3/4. But there are going to be times here where we're going to have an unknown value. So there's a variable sitting there that we have to find. Take it and multiply it with the diagonal, so it gives us 5x. And remember, you always put your coefficient first with the variable. It's not x5, it is 5x. Then we have to take our 4 times 7. So we set it up this way, the very first one, so that we know what we're multiplying. Then multiply your two integers. And then look, we have one-step equation right here. This is your one-step equation. We've done that before. This is multiplication. What stops the multiplication? Division. Okay, so when I divide by my 5, those two cancel out. And then I just take my 28 and divide by 5 to get 5 6/10. Now, not every time are you going to get an integer. There are times you're going to get decimals with this. Okay, so you're going to need to make sure you pay attention to your products and division. So let's practice them together. Okay, so let's look at, is x fifths equal to 15 25ths? Well, we need to find out what x equals. They're telling us it is equal and that it's proportional. Okay, so we are going to solve, and then of course we are going to check. Okay, so going diagonally. Okay, so here we have the proportion x fifths equals 15 25ths. Okay, so when we look at this, sometimes we are lucky that we see they have a common denominator. So when I look at 15 and 25, their greatest common factor is 5. So if I divide both by 5, what do I get? Well, I get 3/5. So right there tells me that x then should equal 3 because this is where my fifth is and that's a fifth. But that's not always the case. So let's look to see how we would solve this using our cross products. So I want to take my 25 times x, they are diagonal from each other. Then we take our 5 times 15. Now you can use the parentheses or the dot. Then we make our one-step equation. Oops, I forgot my 25. 25 times x equals 5 times 5 is 25. And we get 75. Then I have my one-step equation. And I know I can divide by 25. That's what's with the variable, and we want to isolate the variable so that we can solve it. Okay. Then we go, okay, if I have quarters, how many quarters do I need to make 75? So x equals 3. Same thing that we got over here that we got over here. All right, what about 3/4 equals 12? Well, look at it like, all right, I know if I multiply 3 by 4, I get 12. So then theoretically, whatever you would multiply 4 by 4 would get what our C is. So then we would have 12 16 equals 12 C. Oops, I wrote 6. So that would tell us C equals 16. But doing it our mathematical way of cross products, I would take my 3 times C and then my 4 times 12, or 12 times 4. Okay, take your one-step equation. 4 times 12 is 48. And I'm like, ooh, I have a one-step equation. Divide by 3 so that we cancel it out. And 3 goes into 48. 4 goes once, 16 times. Okay. Let's go down to the other two. Okay, 16 and 24. Those are some really hard numbers. They're a little bit larger. So what I really want to reduce, I don't know how to get 24 to 15 with a multiplication or division. There's no integer that is really nice for it. Okay, so we don't really want to do that method for this one. You're going to have some that you're just going to have to do your cross products. Okay, it's just unfortunately no way around it unless we're going to really try to bust it down some. Okay, so 16 times 15. That's 30, 5, 6, 7, 8, and then 16. So we get 240. 24z equals 240. And then, of course, we have multiplication. The inverse of multiplication is division. Whatever you do to one side, you have to do to the other side. We've been doing one-step equations since December. All right, so we are saying that 10/15 equals 16/24. Now, it might not look like that right now, but technically we could reduce these down even more. 10 and 15 I can divide by 5, and that would give me 2/3. I could divide this by 8 and get 2/3. So that is a way to know, ooh, they are equal. But going straight from multiplying or dividing like we did with the first two examples is a little bit more difficult. And especially with, what am I going to multiply 6 by to get to 7? You know, it's only up by 1. So once again, we are going to want to just do our cross products. Right? So then take your 7w equals 6 times 2 and 8 tenths. So 6 times over here, we get 48. We get 6 times 2 plus 4, 16. We get 16.8. We have 7w equals our 16 and 8 tenths. Then, of course, that's the multiplication, the inverse, so that we isolate w. And then we can take our 16 and 8 tenths and divide by 7. 7 goes with 16 twice, or 14. And it goes into 28 4 times. 0. So we are saying that we have 2 and 4 tenths 6 equals 28 sevenths. And there is a way to eventually get down to it. I know I could take 7 into 28. And if I took this one and divided by 6, we would get 0.4 over 1 equals 0.4 over 1. All right, but most of the time, this is how you're going to want to solve with your cross products. Okay, so after 2 hours, the air temperature risen 6 degrees Fahrenheit. Write and solve a proportion to find out the time it will take at this rate for the temperature to rise an additional 12 degrees. So we are going to compare it as temperature over time. Okay? So the temperature when we started went up 6 degrees. This was after 2 hours. We want to know when it's 12. And then how many hours is that going to take? So then you're going to take your cross products. So I have 6h equals, and then what is 2 times 12? So I really have 6h equals 24. Divide by 6, and h equals 4. Well, what is our actual answer? It will take 4 hours to rise 12 degrees Fahrenheit. And there we go. All right, so then you have an exit ticket to do, two proportions. Use your cross products, make your one-step equation, isolate the variable, and that will give you your solution. Have a great